In our recent visit to the Oxford Museum of Natural History, we became fascinated with flightless birds and how they came to be, more specifically penguins. There are over 17 different species of penguin that all trace back to a single ancestor, Manu mangaringi, which lived 61 million years ago. Albatross, seabirds and petrels are the closest living relatives of the penguin, which all shared a common ancestor before they evolved into the species they are today. One of the most intriguing factors of penguin evolution is how their environment contributed to the evolution of flight loss and how they are adapted to their habitat.
Fossils first discovered in China led to the belief that today's birds originally descended from dinosaurs. The key fossil in this theory is that of the Archaeopteryx, which is known as the first bird species. The Archaeopteryx was covered in feathers and is believed to have had the ability to fly. Originally, feathers evolved on these early bird species to act as insulation, and was followed by the evolution of wings by the loss of their fourth and fifth digits and an extension of the second digit. Wrist bones merged to form a semicircular shape that allowed the wing to rotate in such a way to create lift during flight. Scientists believe that penguins may have evolved from a diving bird capable of flight similar to the thick-billed murre. The evolution of flightless penguins from a bird similar to this species would have involved a decrease in wing size, making flying less efficient than diving. Their bones also became more dense to make them less buoyant when diving. The earliest discovered species of penguins is Manu mangaringi, which existed around 61 million years ago. This species lived in what is now the South Island of New Zealand. Ancient penguins were able to colonise the oceans after a majority of sharks and underwater dwelling dinosaurs had been wiped out, allowing penguins to take advantage of an ocean free of predators and competitors. Ancient penguins had a much longer and narrower beak compared to modern penguins, and a longer wing, but still shorter than today's flighted birds. Manu mangaringi was very similar to modern penguins in terms of an upright posture and short stubby feet.
There are many qualities of penguins which enable them to be classified into different species. This is identified by their height, weight, colour and pattern of coat, as well as their geographical location. For instance, the emperor penguin is the tallest and heaviest of all penguin types. Other factors such as behaviour and food source can be considered in classification, however are unreliable when identifying extinct species. By further research into the classification of penguins, we were able to create our own dichotomous key which identified 17 species of penguins.
The diversity of penguins is very large, as there are 17 species ranging from the largest penguin, the emperor penguin, to the little penguin, which is the smallest. Some of these species have special adaptations and behaviour that help them live in their environment, such as the Galapagos penguin, which is the only penguin to be found north of the equator. It protects its eggs and chicks by keeping them in holes in the rocks, protecting them from the sun. The African penguin is another penguin that lives in a hot climate. They have a pink gland above their eyes. This gland gets sent hot blood when the temperature increases. This blood can then be cooled down by the cold air. Some penguins, such as the erect-crested penguin and the Fiordland penguin, lay 2 eggs, but usually only the second egg hatches. The first egg is normally a lot smaller in size and gets neglected. A possible explanation for this is to make sure there is at least one healthy offspring, but the reason is still unknown. Macaroni penguins show the behaviour called porpoising. This is when they swim close to the top of the water and jump out at intervals and take a breath while they do this. This helps them avoid predation as well.